Hey everyone, how are we doing? We are back. It is time for office hours. Who has questions? I'll wake up Mubot here. Uh aw. Thank you right there, Colin. It's just chill, isn't it? We were doing quotes today in class. It's so cold outside. Like hands are like freezing. It's so cold. Chapter 7 quiz. What do you want to do, Riley, on it? Let's do some chapter 7 quiz. Let's do it right here. Chapter 7 quiz. Do all the questions. Got Colin in the chat. Let's throw some 5,000 points for Colin being here. Oh my gosh. I think I froze outside. How is it March and it is frozen outside? How is it March and it's frozen? Taking the family to Epcot. Thank you so much, Colin. That is awesome. Do that. Have fun with the family. Enjoy. I bet they are super excited. I bet they love visiting you. They're like, we're going to go visit Colin, and he's going to take us to Epcot. They must be. If you didn't know, Colin works at Disney, and when he was here, he was like, I'm going to work at Disney. And I said, you make that happen. And then he made it happen, and now he works at Disney. So that's one of the coolest things to me is when a student has, basically at UT, they just have a goal, and they make that goal happen. And that's what really I like to see right there. With that, which one should we do, Riley, from Chapter 7 quiz? Chapter 7 quiz questions. Live bursts. Let's do it. Birth rates. Okay, the live burst question. Got it up on the screen. Gonna pull up a Word document. Okay. Let's go check it out. I'm going to take the note. Video. Okay. It's like I'm frozen. Okay. Stat 201. Chapter 7 quiz. From a Pearson live burst. Let's check it out. Okay, the table shows the live burst right here. And so when you look at it, what is the relationship you see between as year goes on and rate of birth? As year goes on and rate of birth, what do you notice? As year goes on and rate of birth, what do you notice? As year goes on and rate of birth, what do you notice? As year goes on and rate of birth, what do you notice? Like year increases, rate of birth gets smaller. So which of these graphics looks to be that way? A, B, C, or D? If you notice as the year gets higher, rate of birth gets lower. Which graphic looks to be our answer? Great job, Riley, right there, following along. Looks to be C. Great job, Daryl. Good to see you, earning us all some points. Now we're going to take this data and bring it into Jump. Watch these steps right here on how to get this data into Jump. There is a trick that I used to get wrong, but I don't get wrong anymore. We're going to go here to the arrow and go copy to clipboard. Yeah, let's do Canvas content too. Emily will definitely do that. Copy to clipboard right here, and then you want to hit Control-C or Command-C versus PC or Mac. And now go over here to the data table and hit Control-N will open up a new data table or File, New Data Table. Now don't click inside of it. That's why I use Control-N. Don't click inside of it. Go to Edit, Paste with Column Names. Edit, Paste with Column Names. So now that we've pasted with the column names, we're halfway there. I can't sing. Double-click this column to initiate a new column. You just double-click it. Now that you've double-clicked it, right-click it. Go to Formula. So we double-clicked the column, and then we went to Formula. Now you're going to click Year and do minus 1900. Click Apply OK. Once again, that was double-click to create a new column. I'll do it over here. You don't need to make a fourth. I'm just showing the steps again. I don't need to make a fourth. I'm just showing it. Right-click to make a new column under Formula. Double-click the year or single click it, and then do 1900 minus, and then click apply and OK. You don't need to do it. You can double click up here to rename it, and we could say since 1900. You don't have to rename it, but you can. And so now we have the correct way they want the variable organized. So make sure you've done these steps, slow down the video, and ask questions if you got them. So now we're going to do the regression model here by going to Analyze, Fit Y by X. Analyze, Fit Y by X. You're going to go right here and do years since 1900 as the explanatory variable, explaining the rate. Make sure it's the years since 1900 because that's the way the problem will be calculated. So with this, we're going to click OK. Now we're going to go here and do the red arrow and go to Fit Line. Now we can make our life easier by going to the red arrow again and going to save predicteds. Save predicteds. So now we've actually got predictions saved in the model. That must have been a whole number, very close to it. So we've got the predictions saved. And for other questions, we might ask you to do things like add a residual plot, which is a plot of all the residuals, which is the line flat. Notice that there's these points in the middle, which go above, below, below, below. And if you go here to plot residuals, you can see that same pattern right here. Well, where is it? Where's my residual plot that I like? Have I gone mad? Oh, there it is, above, below, below, below. Those are the points up there. And there they are right there. It's just very hard to see with the line flat today. But those are the points, and there they are right here. There are the points, and the 2 points at the end of the model. Did it reverse my model? I guess it did. I just take the line, usually make it flat to make the residual plot. My favorite way to make residual plots. So with this, what are the 3 quantities you have to interpret for the test? For 1,000 points, people should know this. What are the 3 quantities you're going to have to write written interpretations, and then I'll interpret them for you? So if you followed all these steps, we'll probably be able to do the question in about 1 or 2 minutes after this. What are the 3 interpretations? What are the 3 interpretations that you'll need to do for the test? So try writing them down for this question. It'll have you do it. The r-squared, the slope, and the intercept. The r-squared would be about 80% of the variation in the rate of birth is explained by years since 1900. R-squared is blank percent of the variation in y is explained by the variation in x. Mubot's putting it in the chat right now. The slope, and great job, Daryl, right there. The slope is this quantity right here associated with the x variable. For each additional year since 1900, we expect the birth rate to decrease by 0.113 on average. The intercept is actually going to be related to the year 1900. So the intercept is when x is equal to 0, we expect y to equal b0. This is the value of b0 right here. And we would say when it is the year 1900, because when x is equal to 0, which is years since 1900, we would expect the birth rate to be 25.61. And I think that's in thousands of births or so. We'll find out. The intercept is just for the year 1900. Now, the save predicted is going to be very important for later on this problem where we have saved the predicteds right there. So we'll use that later. Let's see what the problem asks us. So for this problem, great job in the chat. Describe the trend. Well, it's decreasing over time. Pretty easy to see. Write the regression equation. We just have to find the slope and the intercept, which can also be down here in the parameter estimates. So the estimate of the intercept is 25.61. So 25.61. And then negative 0.11. So just make sure to take those parameter estimates. The estimate of the slope and the estimate of the intercept, B0, B1, are the intercept and the slope respectively. Intercept estimate is that, slope estimate is that. It's also up here in the regression equation. The intercept comes first. This is B0. And then after that comes B1. And then after this comes the value X and Y. So that's the way the equation is written in its general form. And you can see the values of the slope, oh my gosh, the intercept and the slope right there. And just make sure you've put them in correctly. So now check to see if the line is an approximation appropriate model to use. And for this, we mainly see if it is linear, if it follows it, if there's big outliers. And the answer is, looks pretty good. Doesn't have a problem with QQ, straight enough, no outliers, plot doesn't thicken. So I would say the line is mostly appropriate. It's reasonably straight with no outliers. We can't say if there's really lurking variables because we don't know if there's outside variables. Manager at a bookstore, you got it. I think we'll do canvas content next, and we'll do manager at a bookstore. And let me know which one, part A through H. You copied that in. That's awesome, Daryl. So here's the thing. How could you make a prediction? The slope would be for each additional year, for each equal to this, the number of births that is increased or decreased by 1,000. What would you do with 78 to make predictions with 78? What would you do with 78 to make predictions with it? What would you do with 78 to make predictions with it? How would you use the value of 78, which is the years since 1900, to make predictions with it? How would you use it? What would you do? So it says predict for 1978. So what would you do? How would you make predictions if it's years since 1900 and we're using 1978 and you're making predictions? How would you make predictions with that? Thoughts? And Daryl, you're very close. It's years since 1900, though, so we have to plug in 78 and then times that by 0.11 and subtract that from 25.61 and then times that by 1,000 because it's bursts in thousands. So we have to do that right there. Oops, I misclicked something. It's been decreasing still. Sorry, I misclicked. And so we have to plug this in right here. And I'm pretty, actually, I think it wants the decimal version. Yeah, I think it wants the decimal version. So, and it wants it to one decimal place. So I think it's going to be 17. You just plug 78 in. You literally, does this make sense to right here? You just plug in 78 because it's years since 1900. Does that make sense? So you're plugging in 78 because that's how many years it's been since 1900. Also, you can check your work by going over here and simply typing in. Is it going to let me do it? Am I going mad? Thought I could do that. Oh, the year is here. Just go right here and type in the year. And, oh yeah, 1978. There we go, 1978. This is saying 16.73. I think it must be because we didn't carry all the decimals. I think my Pearson's pretty nice on this one. We'll find out. But this will find out the exact answer. I'm going to make sure both answers work. And now we have the interpretation of the slope and the intercept, or at least the slope interpretation right there, which is the number of births has been changing by this amount per year. Then we have the actual birth rate was 15. So think about this. If the actual is 15, it's what to the model? Above or below? It's below the model because the model would be above it predicting 17. So the model predicts this many more births right there. The birth rate in 2020 has not been figured out yet. So now we go back to our model and we simply plug in 120 because that's years since 1900. Plug in 120 times by this, subtract 2561, subtract that, and we get 12.41. Now this is a light extrapolation because we're not going too far in the future. And then we could actually do some cheating math here, I think. Well, I'll show it. I was going to do it by cheating, but we won't do that. Now it wants 2050, and 2050 is 150 years in the future. We times that by the slope coefficient, take 25.61 and subtract, and we get 9.11. And that's going to be for 2050. Now, that's pretty far in the future. So the first one we would have some reasonable belief in because it's not a big extrapolation. But the next one we would not have. There is really no faith because this is an extrapolation far beyond the data. I think I've done it correctly. I missed something. What did I do? Oh, no. You got to be kidding me. No. Really? Oh, my gosh. That's where you email me and say, Brian, I got 100. So that's where you would email me and say, Brian, I got 100. I want to see if the jump method works. Jump said 16.7. So it should, if it accepts the jump answer, accept 16.7. And it does accept that. And then this answer would change here to 1.7 because that's the difference now. And it does accept that. So you can do it. Can you do it again? You times what I say. So you just plug in right here. I'll write it out. When you're doing the solve with 78, you go and you take the equation. And if you're solving for 1978, you literally go and you take this and you plug in 78 because you're doing for 1978. So you take off the 19 on it. Now, if you're solving for 2020, you would this would be 120 because it's years. You subtract off 1900 as years since 1900. So yeah, that's got it right there. So that is good. Good stuff. Let's do the Canvas content. Who's here for some Canvas content? You will get Canvas content done. No more Canvas content after this. We're just going to like Thanos it away. So who is here for some Canvas content? Stat tool 1. Canvas content. Number 5 or 6 or something. Okay. Oh, it ties it by the slope coefficient. Mm-hmm. So when you solve the equation, it'd be 78 times negative point. So you times this right here. You multiply these together and then subtract it from that. So you just algebra the equation. Does that make sense, Daryl? And ask more questions if you got them. You just algebra the equation, and then when you algebra it, you get the answer. Good questions. Emily is here for some Canvas content. Is it number 5? Is it number 6? It's number 6. That's number 5. Here it is, number 5. I was right on that. Okay. Let's preview the Canvas content. Okay. Let's try this. Adding all the residuals together will sum to 0. Adding all the residuals together will sum to 0. What are your thoughts? Adding all the residuals together will sum to 0. We can draw a quick example of this. We can have a model. It's very true. Nice job, Jacob, coming in for the win right there. It's because some residuals will be negative and some will be positive, like -2, +2, +1, -1. And they will always sum to 0. 0, good to see you there. 0 knows it. 0 gets it. Let's throw you 1,000 points. Thank you for being here, 0. My visitor from another class, another around the world, maybe. You never know. Stats, we're here to do them. So that's very true. How about the next one? For each 1 unit increase in X, we expect Y to increase by B1 on average is the interpretation of the what? Notice how you say 1 twice in this interpretation. For each 1 unit increase in X, we expect Y to increase or decrease by B1 on average. If it is negative, this would become decrease. This is definitely the interpretation of the what? It is the slope. The intercept is when X is equal to 0, we expect Y to equal B0. The slope is for each 1 unit increase in X, we expect Y to increase by B1 on average or decrease if it's negative. The R squared is blank percent of the variation in Y is explained by the variation in X, and a residual is how much we miss by. If it's positive, the actual is above the predicted, and if it's negative, the actual is below the predicted. So this was the slope interpretation. Here we are with some jump output. Now, when it comes to jump output, you should be able to identify what? Here are things you should identify in jump output. I am highlighting in yellow the what? What have I highlighted in yellow? Yeah, Riley, we can do that one. You got it. What have I highlighted in yellow right there? In jump output, make sure you know these. What have I highlighted in yellow? The slope. That is the slope. What have I highlighted in blue? What have I highlighted in blue? What have I highlighted in blue? Can't do orange on that. You never see it. So to color code these, this is B1, which is the slope. This is B0. That is the intercept, B0, highlighted right there in blue. It's in 2 spots. It's in the equation and the estimate. Next, you have the name of the X variable right there. The other one's the Y variable. Finished time is the Y variable of interest. I didn't highlight it, but it's over there. And then last but not least, what is highlighted in green? What is highlighted in green? Great job, Zero. Or Zorro. Please tell me if I mispronounced anyone's name. I think Zorro is how it's pronounced. What is highlighted in green? Oh, and I should have done one more. P-value of the slope, which is the significance of the model. P-value of the slope. Because if you look along the slope line right here, it's the p-value of the slope. What is the one thing for 5,000 points that I forgot to highlight that we're going to have to interpret? What is one thing I forgot to highlight that we have to interpret? One thing that I didn't highlight that we will have to interpret. What did I forget to highlight that we will interpret? We'll interpret the slope. We'll interpret the intercept. We'll also interpret the R squared. 34.4% of the variation in finish time is explained by the variation in age. So we go down here, the R squared, 34.4% of the variation in finish time is explained by the variation in age. Boom. Slope is for each 1 unit increase in someone's age, we expect their time to increase by 2.4 minutes on average, and the slope value is 2.4 right there. The intercept is when someone's age is equal to 0, means you got a baby running the race. I don't think it's possible. I don't think a newborn baby. I was just born a moment ago. So with this right here, the newborn baby would be expected to have a time of 1:56.5. They'd be like the fastest person in the race. Don't really think that's possible. It's an illogical intercept. The correlation coefficient is 0.5. What is the R squared? So how do we get R squared from correlation? The correlation coefficient is 0.5. So how do we get R squared? We'll do one more version of this, then we'll hop back to doing some Pearson. So it's asking what is R squared. So this one is very easy if you know what. You just have to know one fact, and this is easy. I think Emily's basically saying it, because Emily, I think you know this. Let's throw you some points here. You know that this is correlation. So this is R, so you square it, and that's it. It's just R squared, and that's correlation. So just take the value of correlation, which has been given, With that, we go 0.5 and square it. And that's it. That's all it is. Now, if you see B0 and B1, think of an E word that you want to write out. If you see B0 and B1, what might you want to write out to be able to solve this? We'll do one more version of this. You might want to write out your what? You might want to write out your what? If you write this out right here, it's really easy. It gives you all the values. Just write out the equation, right? So all we do is we just write that the predicted value right here is 27 because the intercept, well, we can find residuals. So this is not, good answers, Emily. This is not the residual equation yet because this one doesn't ask for the, oh, it does say, it says find the predicted. No, it's saying find the predicted, yeah. We can also find residuals with residual equals actual minus predicted. And these are the two equations we should know. This is the equation to find a residual, which is how much the actual and the predicted are off by. And this is the equation of the regressional line, which says that the predicted value of y is equal to the intercept plus the slope times the x variable. The regression equation looks like this right here. This is the regression equation. And the regression equation leads to the value right there, which then when we have an actual point, which we'll call the actual points, the green dots can have a residual, and the residual E is how far they are away. So the residual E, which highlighting in yellow right here, is the distance between the actual and the predicted. Does that make sense, Emily, right there? The question doesn't really go into that big of detail, but the equation on the left highlighted in yellow is actual minus predicted is a residual, the actual being the yellow or the green dots, and the predicted being the line of prediction, which is from y hat, which is the prediction line from the slope and the intercept equation. And so down here on the bottom, I kind of solved it in my head a little bit because we can take the slope coefficient of 2 times it by the x of 8, and we're literally just taking these values and plugging them into this equation. And it leads to 16 plus 11 equal to 27. Is that the commutation problem of addition? Something like that. And that should be 27 right there. Not that, once you know how to solve that one, it's pretty easy. We'll do one more version of this. We should get a 10 out of 10. We get those 10 out of 10s. And we got 2 more questions. Okay, adding together all the residuals will definitely solve to 0. That is a fact. For each one you increase in x, we expect y to increase by b1 on average. That is the slope. We did this one previously. Do we not get? Might need to do one more version because we just got the same version mostly. Ooh, here we go, Emily. Here's one for you. So with this one coming up right here, it says if the residual is this and the observed is this, what is the predicted? So now, look at this. How should I notate residual? What on this screen is a way to notate residual? If you look at the screen, where is residual? Where have I used it? Where have I written residual? What is the actual notation of residual? I write R a lot of times for residual. What is the actual notation in statistics for residual? The actual, like, it's E. The actual notation is E when you write it in statistical notation. I call it R a lot of times for, like, residual equals actual minus predicted. The actual value, which are the dots, are the Y, and the predicted is the Y hat. So we just write the equation right here that the residual equals 2.6. And then the observed is what it actually is. So 25.7. And then minus some value x right here. So x must be smaller. So it's going to be 23.1. And you can check your math by plugging in. You can also just subtract from both sides. Like if you subtract, you'll get negative 23.1 equals negative x. And then 23.1 equals x. So just solving it that way by subtracting this over on the other side, but then you have negative x. Does that make sense on the algebra I just did right there, Emily? That you can solve the equation just writing like residual equals actual minus predicted. Another word for actual is the observed. And so it'd be 23.1. And then you can also just check your math to make sure everything maths out. So it's all about solving that equation right here and making sure you have it. Nice job, Emily. And please slow me down if I ever go too fast. I've done these problems a lot. We'll do a really quick one more version to see if we get anything new. If a residual is positive, what was larger? Say it with me. We've done this one a lot. If a residual is positive, which was larger? It's almost like I've seen this on Canvas content and seen it on the test. If a residual is positive, what was larger? What is larger? Don't worry about being wrong. Although, yeah, don't worry. You're like, oh no, if I say it and I'm wrong, it's bad. It means you learn. I should ask questions people get wrong. The more I ask that people get wrong, the more people learn. The dot is above. So when something has a positive residual, it's above the prediction. So like this point right here has a positive residual because it's above where it was predicted to be. Notice how it's above the prediction. That is a positive residual. If you're above the line, the actual point is higher than the prediction line. The residual is positive, so it has to be above the predicted, so the observed would be lower. The prediction would be lower. The observed has to be higher, so it would be above. We did this one a billion times. For each one unit increase, we did that. It's the slope. Adding to other residuals is sum to 0. And we've done it. So do you have a 10 out of 10? I hope you do. You can say if you want, but my goal is to get people these 10 out of 10s. That's the goal right here. Get those 10 out of 10s. I think I got it. I was doing it by memory. Slope might have been wrong. Nope, got slope right. There we go, 10 out of 10. Just going by memory on what I thought the slope was. Okay. We've got manager to bookstore and another one. The manager to bookstore, let's do that one right here. It's got parts A through H. Okay, it's a very similar one where you have to do a lot of math behind it. Stop auto-completing. I don't want 500 subs. Okay. So we are currently at the 28:13 mark, or 12. Let's do that. Chapter 1, Chapter 7 quiz. The manager to bookstore. Okay. Here we go. The manager at a bookstore. Okay, let's do it. So where are we going to go to solve this? You're welcome, Emily. How are we going to solve this? We're going to put it into what? How are we going to solve this? We need to take this data and put it where? Help me out. Where should I go? What should I do? Brian, take this data, put it where? Where should we bring it? Jump. Jacob knows right there. We're going to go up to here. Good job, Riley and Daryl. We got this. We're going to copy to clipboard. Then we're going to hit Control-C or Command-C and hit done and done. Then we're going to go down here and we're going to go to a new jump table by going to File, New, Data Table. Then you're going to hit Edit, Paste with column names because it had column names up at the top. And now we have it. Now you have to go to Analyze, Fit Y by X. Analyze, Fit Y by X. With Analyze, Fit Y by X, you need to enter in, we are trying to understand why we get so much sales, and maybe the people working explains it. So maybe the number of workers explains why there's so much sales. So let's go ahead and click OK right here. Does this look like a good linear model? What do you think? Does this look like almost my Pearson set up a problem with the perfect linear relationship? What's your thoughts? You look at this, you fit your line, you go to the red arrow, you say, let's add a line to this data. And you say, oh my gosh, textbook problem looks amazing. Little curvature right there. Little weirdness. Nothing too weird. You gotta give it forgiveness and say, it's all right, you tried. So this is a pretty good linear model. What is the intercept? Just a very basic question, not interpret yet. What is the intercept? Very basic question. What is the intercept? Very basic. You have to now read the output. Where's the intercept? What is it? You can tell me to one decimal. Just what is it? Not interpret yet. What is the intercept? You should know that quickly by looking at the output. You should be able to look at me like, oh, I see the intercept. Yep, we did live burst at the start. Check it out. It was the first question 3 minutes into the stream. Check it out. Very start. If you rewind time, live burst was done. 9.73. Thank you so much, Bridget, for asking. We did the start. 9.73. Then next, we have the slope after this. You're welcome, Bridget. And the slope is right here. And that, make sure to put the 0 before it. And then the name of the X variable is right here. So it's Y hat, predicted sales in thousands of dollars, is equal to the intercept plus the slope coefficient times the X variable. Maybe we'll have to write out slope and intercept interpretations. So the intercept would be when salespeople is equal to 0. Doesn't really make sense. We would expect to sell $9.7 thousand. It's in thousands of dollars. The slope is going to be for each additional person working at the store, we expect sales to increase by 0.779 in thousands of dollars. The R squared, which we also have to interpret for the test, is going to be 93.16% of the variation in sales is explained by the variation in number of people working. You do also have to know for these chapters, we do make a residual plot to see if there's issues like plot thickening. So we often plot the residuals right here, and yeah, no, it looks pretty good. A little weirdness, but it looks pretty good. It has about the same thickness throughout. It doesn't really, you say that's not really that much thicker. There's not that many points, so this is a hard one to tell. We'll usually give you something fairly obvious. I don't know if I still have it up from earlier today. I do. If we want to point to there being problems, we will usually do something a little more obvious on the test like this, like where it's nonlinear. And if you go and look at the residual plot, you're going to be like, that has problems. You're going to say, wow, just craziness.
Wow.
That is plot thickening. And if it got thinner or thicker in any direction, that's bad. And also nonlinearity. And that is the residual plot. Look at all the residuals at once. Look at all those points above the line. And they're still above the line down here. It's just the line made flat and the line is set to 0. That is a residual plot, which allows us to analyze all the residuals to see if there's problems. So we do have the coefficients of both the intercept and the slope right here. 9.73 and 0.78. Let's go back. 3 decimals. No. This is the coefficient of the slope. The coefficient of the slope, or just its numeric value, we call it the coefficient, is this right here. This is known as B1. For each 1 unit increase. This means on average, for each additional salesperson working, we get approximately this many more dollars in sales. The intercept is B0, because it's when x is equal to 0. So this is the expected value of sales when nobody's working. So right here, B0. And this is, it means that on average, the total sales, 0 people working. The expected sales when 0 people are working. This is the intercept. And the slope is positive, very important for all questions. If 19 people are working, what are the predicted sales? If 19 people are working, what is the predicted sales? Daryl, how are we going to solve this? Or anybody, how are we going to solve this? If 19 people are working, what is the predicted sales? How are we going to solve that? If 19 people are working, what is the predicted sales? What are we going to do? There you go. Yeah, just take 19. Plug it in. That's what X is. X is number of people working. So we're just going to plug in this right here to get predicted sales. So we go and we plug 19 times 0.779. And then we go right here, 9.730. 24.531. That is the predicted sales. Now here's the thing though, times 1,000. So they actually do want you to convert it on this problem and round it to the nearest tens of dollars. And there's the answer right there. There is the predicted sales. So is the actual higher than the predicted, or is the actual lower than the predicted? So this is the actual. It is water to the predicted. It is water to the predicted. The actual, is it higher or lower? The predicted's the line. So the actual is higher or lower? It's lower. So the residual must be what? The residual must be what? If the actual is lower, so here is the prediction, and the actual is down here, and the prediction is up here, the residual must be what? The residual must be what? Hint, not positive, negative. So remember, it's actual minus predicted. So when you do actual minus predicted, we get a negative number. There we go. So has the model over or underestimated it? I'm not going to show you, but if I show you, you'll see it. Has the model over or underestimated? I'll give you a hint. The last 2 people who answered this got this wrong. Boom, Daryl, first person to get right worth 5,000 points. The model has overestimated. You are correct, Daryl. First person in a while, because the model is up here highlighted in blue. The predictions of the model have overestimated it. So when you have when you have a negative residual, the model is over it, and the estimates come from the model. Daryl, first person to get that right out of 3 people. And man, I'm proud of that right there. So don't worry, a lot of people get that one wrong. The model's overestimated because the residual is negative. The model's over top of it. What? Where did I go wrong? 3 decimals. I might have misclicked. Let's see. It means that on average, the expected sales is... Yeah, that's right. 3 decimals. Means that on average, the number of salespeople working is approximately... No, I did the wrong slope. This is it. This is slope. It means that on average, an additional this much in sales... I think... There we go. I am pretty certain, unless I super misread... But I misclicked it. There's me explaining everything. Look. Wait, Daryl, do you see it? Daryl. What did I click? Did I actually get 100? When did this happen? Wait, oh. Ha! Sorry. You hear me in the next room over probably. What did I just... What did I do? It means that on average in illustrations... Yeah. Why did I do that? I don't know. I'll have to look at what I was saying. Yeah, no. It's that one. It means for each initial salesperson working, we expect sales to increase by this much on average. It's easier when you write it out. Yeah, no, that was totally like a misclick or something. It means on average the number of salespeople working is approximately... No, we're not predicting salespeople. So we're not predicting salespeople. We're predicting the money. Because in the equation, we're predicting money. So it means on average, we expect an increase of this many in dollars. I've done this question a ton of times. I was just like, where did I go wrong? Researchers collected the mortality. And this is the hardness of water. Hardness of water. Let's get some hundreds. I can't do decimals today. It's one of those days. The cold's getting to me. Chapter 7 quiz. Okay, researchers collected the hardness of water. Oh, it's almost like I know where that one's at. Oh, it does a lot. Okay. How would you describe this relationship, Daryl? How would you describe this relationship? Don't even read their answers. Don't look at their answers. Hard water has more calcium. The bottom axis says calcium. It is definitely a negative. I would say it's strong. Good work, Daryl. Don't read their answers yet. Always think about what you would say. And over here is harder water because it has more calcium. Soft water has little calcium. And you notice there is a negative relationship that harder water tends to have lesser mortality rates. Doesn't mean it causes it. It just means we see an association. There's a fairly strong negative. That means we are down to these two. Towns with harder water tend to have lower mortality. So you have to know that fact that more calcium means harder water. This looks a lot like our jump output, right? You know how jump output looks? We're jump output down here. So in our jump output, on the jump output, what is the estimate of the intercept? In the jump output, what is the estimate of the intercept? So just in the jump output, what is the estimate of the intercept in the jump output? Only in the jump output up here. Where's the estimate of the intercept? 9.7. So where do you think is the estimate of the intercept here? If that's the standard error, and that's the standard error, and that's the t-ratio, and that's the t-ratio, and that's p-value, and that's p-value, and probably just go right here, and the intercept is the coefficient of the intercept. It just means numeric value. 3 decimal places, 865.507. Looks a lot like jump output, so I like this question. Negative, do not forget that you can't get points back if you don't do the negative. So that's very important. Great job, Daryl. You see it. So this means, think about the slope right here. For each additional 1 unit increase in calcium, we expect the mortality to decrease by negative 2.976, or by 2.976. So for each additional point in calcium, the model predicts a decrease of this. Explain the meaning of the y-intercept. It'd be a town with the most softest water ever, which I think is also bad. You want, I don't know. So the town that has 0 calcium is expected to have a mortality rate of 1,865. So this model predicts a town with a calcium of 0 would have a mortality rate of the intercept. The largest residual was this. Explain what this value means. If the largest residual is positive, what does this mean? This town has more mortality, or this town has more calcium? Or less. Maybe I'm wrong. If the largest residual is positive, and let's say it's this point here, and it's 96 where? The town has what? It's making it very easy to see, like that's the highest residual, the largest, the one that's most above or below. Well, the y-axis is this. So it would have this predicted. This is its predicted amount. And this is its actual. So what does that mean? Its mortality rate is what? Because the line gives predictions. Yep, exactly. The mortality is 96 higher than actual. And the calcium is the same. You're not changing what the calcium is down there. The mortality rate is 96 higher than it would be predicted to be. So it's 96 higher. So it's 96.2 more deaths than the model predicts per 100,000. That one has caught me. Per 100,000. They're like, whoa, per 100,000. Don't forget that. I've gotten that one wrong before many a times on this question. Do not forget that. So don't want to get that one wrong. The hardness of a town's municipal water is 114. Use the value in the regression model to predict the mortality rate in this town. Okay, so 114. What do we do? Daryl, we've said this a lot. What do we do to make predictions with the model? And then it says in 100,000, so we're not going to multiply. Oh! Hiccup right there. What did it say, 119 or something? Plug it in. There you go. 114. And go right here. 114, and then just start solving the math. So 114 is the x value times 2.976. Now what I'm going to do is I'm going to type in, I've copied that value, and then I'm subtracting it from this value. There we go. And what you should see, 1526, if you look up the model and you go right here and you trace up to where that would be, it'd be about towards the middle. You should be about 1526 or so. So that kind of makes sense. It has to be between these numbers, more towards the middle. You shouldn't get a crazy number. You should get a number that makes logical sense for around where 114 would be at. Explain the r squared. It's blank percent of the variation y is explained by the variation x. So the r squared was 93.7. They've already done the 100% of it. So 93.7% of the variation in mortality can be accounted for by a linear model on calcium. So, and it's the variability or variation. We should be right. Come on, we got it. Let's go. Oh, man. There we go right there. I like that. Good stuff. Next question, Daryl. We got time for at least one or two more. I thought someone else had another one. Calluses on my hands. Getting rough. I feel like sometimes when I'm like doing pull-ups, I start doing pull-ups like this, and by the end, sometimes like that. I'm like, is that a good idea? They've got like these grip things you can get for like pull-ups where you can make it like harder and make it so you have to like, I guess it's for grip strength. It's kind of crazy. Like I already feel like, I don't know. They've got like these big grips things you can use, especially you can put them on like bars and stuff like that, and just like, now it's harder. You get to really try. It'd be fun to get. Maybe I'll buy those. I get to buy one workout thing a month. That way I don't like buy a billion things and don't use them. You buy a bunch of stuff, you don't use it. What's the point? It's wasting money. It's gotta say like, well, I'll buy it, see if I use it. If you have to do anything other after plugging it up, nope, you just plug it in because you're doing the predicted. So with F, it's just a predicted. Plug it in, solve the equation. Does that make sense, Daryl? Good question. Just plug in 114. You can, like when you solve it, I solve this out. I go 114 times 2.976. And then you take and subtract the 1865. I'm copying the number. It's in my copy right now, subtracting that number. There we go. So it's, yeah, you subtract that value off of it. So just make sure to algebra it out. You can write it down, put it in the calculator, look at stuff like that. Let's see, we could do some easy peasy ones. No one ever wants to do the easy ones. Everyone wants to do the tough questions. Make me do all the tough questions. 45, 53. Let's do Stat 201, Chapter 7 quiz. Quick, easy question. I wonder if people watch these. Let's see. Manager at a bookstore. What does the value of r squared mean? Here we go. R squared is down here at the bottom. It's 98.2. So 98.2% of the variation in y is explained by the variation in x right here. Put on despair music right there. 98.2% of the variation in y is explained by the variation in x. So the variation in y would be percent of the variation in sales can be accounted for by a model of Sales on number of salespeople working, 98.2. Check answer. What'd I do? My brain's blinking. 98.2. Well, then it has to be this one. In sales. I think I got the wrong value R squared. What have I done, Daryl? Daryl, what did I do? I want you to look at something right here. Okay, Daryl, it is the first answer. And what did I do? Do you see it at the bottom? What did I do? What is the problem here, and what did I do? What did Brian do? I see it. I thought it was so nice to me, and I was like, oh, really? You just want me to... Didn't square the R squared. So 0.982 times that. There we go. And then go back to here. It is the first one. That's why I was going to do problems too quick. And then it wants to 1 decimal place. There we go. That'll do it. There we go. R squared is correlation squared, but it's not correlation, so make sure to do R squared. R squared. Not, yeah. General question, but when the quiz asks us to guess the value of the extrapolation, how do we find that? Do we look at the slope? Which one is it? Sarah Beth, which question are you working on? Oh, you want to do residual plot patterns? Let's do those. Tell me which question you're specifically working on. I'll do that one. It's the years question about the... What's the years question say? Is it the one we've done? Is it asking you... If you tell me which part... I'll do the residual. I'll sleep. Okay, and then we'll do that one next. Sarah Beth, you got it. Okay, so with residual plots, how do you want residual plots to look? How do you want residual plots to look? How do you want a residual plot to look? You'd like residual plots to look what? You want residual plots to look what? Random. You got it. You know it. So a residual plot is where you take your model and you make the model flat. If you made this model flat, it would look most like which graphic? A, B, or C. If you made this model flat, like you took this line right here and made it flat, you made the line flat and looked at the points around it, would look like A, B, or C mostly. Probably it would look most like what? It would look most like what? A, B, or C. Ah, it would look like A. C would have a plot that looks like this. B would have a plot. Oops. It can be a negative line. B would have a plot that looks like this. Do you see kind of how I tried to draw the same pattern in them, but the line is just flat above? Because usually you can take and draw your plot and put the line through the center, and it's a residual plot. And you see the same pattern down below. So A is actually a very good residual plot because it shows no real patterns. G and H, awesome. And then B is a bad residual plot because the plot gets weaker as it goes on. So it's getting weaker towards the end. C gets stronger as the model goes, but we don't want the plot to thicken. These are fanned patterns. So A shows no patterns. The linear model is appropriate. B shows a fan pattern, indicating the model is getting weaker as it goes on because it's getting more spread out. And this one would show the model's power increases, which is the reverse of it right there. Might be other versions of this one too that might show different things. Oh, these show a what pattern. Those one up there, A and C, now show a what pattern. In the residuals, you notice a what pattern. Both A and C a curved pattern. And that's because if you had your model, it might be that your model looked something like this, right? Actually, you need to go up like this and down like this. This one would come from a model that looks like this right here with the points spread out, and then they get tighter. We call residual plots diagnostic plots because they allow us to diagnose issues. So you take the line and you make the line flat, and that gives you a residual plot. So a residual plot is a diagnostic plot to see if there's issues. Both of these have curved patterns. This one shows a model that is getting stronger, so the predictive power of the model is increasing in those. Residual plots should show no patterns. I think that's all the variations on the question, but it's a very good one right there. Residual plots should show no patterns. They should look completely and utterly, you get it, random. Parts G and H of the years question. Well, how's the years question? Is it the one we've done? Is it the years right here? Is it this one? Oh, and you're talking about the predictions, right? I think these. So you say, oh yeah. So how do you solve for the year? What do you do to predict for the year 1900? Thank you so much. Or the year. What do you do to predict for the year 2020? How do you make predictions for the year 2020? How do you make predictions? It says years since 1900. So what do you do right here with this equation to make predictions for the year 2020? How do you make predictions for the year 2020? How do you do it? This says years since 1900. So if it's 2020, what would you plug in here? It says years since 1900. So if it says 2020, what would you do? Got time for one more, I think. Bingo. And then plug this in. Yeah, and then just math solve that out. Does that make sense? That'll be the predicted rate. Yep. Fuel economy, combined miles per gallon, displacement of liters. Let's do it. I'm going to sleep. Only got 7 hours last night. 7 hours of sleep. Start putting the year on these because, like, I look back and I'm like, when did I do this video? I've done a lot of videos. Yeah, let's do it. Then we might have time for one more. All right. Let's do it. In the words of Michael Baum, let's do it. Residual plots. It's analysis. Ah, there it is. Here it is. Analysis, they give us an equation. Combined miles per gallon is predicted to be 33.469 minus 3.32 displacement. Explain what the slope means. For each additional unit of displacement, we expect the combined miles per gallon to decrease by 3.32 on average. This means that, man, they write this weird. Model estimates the car will lose an average of, nope, that's the displacement, right? Yeah, I think this is it down here. That's the one that catches my eye because the car will lose. It says what displacement is, like the liter size thing. No, wait. No. Sorry. Wow, Brian, come on, man. For each additional, the car will lose this miles per gallon for every additional, yes. No. This is, don't click anything until I finalize because I was double checking. Thank you, Daryl, right there. I'm like double checking. The mall that the car loses on average 3.32 miles per gallon for each additional liter. That is literally it. I couldn't be more sure. Boom, got 100. Yeah. I reversed my X and my Y for a moment because I have to read their interpretations. But for each additional liter size, for each additional X, we expect Y to decrease by this on average. Does that make sense? For each additional, they just put it in reverse order. For each additional liter size, we expect the car to lose about 3.32 miles per gallon because that's what we're predicting. So if you think about it by reading at the end of it, for each additional liter size, we estimate the car to lose 3.32 miles per gallon. So yeah, it helps if you read it that way. I reversed my X and my Y because they did that, and I was looking at it and I was like, wait a minute, I don't think it's right. And then yeah, it jumped to me. It's just easier for me to write them out. For each one you increase in X, we expect Y to increase or decrease by V1 on average. So remember, you will write these out on the test, so you know how to write it out. So here we are with another one. Let's play what the slope means. Okay, let's not look at their answers. The slope, what is the coefficient of the slope here, Daryl? Just don't look at their answers. What is the coefficient of the slope? Don't look at their answers, though. Just what is the coefficient of the slope? So if you have to interpret the slope, you have to know where is the slope. So just what is the slope? (28), that is the slope. Do remember that if you're solving these out, the slope, it goes b0 plus b1x. So great job, Zachariah, too. Does anyone want to try to interpret it? Don't look at their interpretations. But what is the interpretation of the slope right here? This is y hat equals b0 plus b1x. Here's the slope coefficient. So what is the interpretation of the slope? So it's for each 1 unit increase in x, we expect y to increase or decrease by b1 on average. Don't look at their interpretations. Because we can then look at ours and see if we get one that's good enough to use that we can find theirs with. What would it be? I'm going to probably start my Monster habit again. Bad Brian. Drinking Monster energy drinks. So good, though. Give you that, like... Just... Sometimes my skin tingles on Monster. It's not a good effect, is it? It's like... Oh, for each unit increase by... Ooh, good... So wait. Good, Zachariah. Good work. We're throwing you 5,000 points for going out on a limb there. It's going to be for each 1 unit increase in fiber, which is the x. For each 1 unit increase in fiber, we expect potassium to increase by 28 on average. So look at how Mubot said it right there. For each 1 unit increase in x, we expect y to increase by b1 on average. And that's why we practice these things right here. Good work, Zachariah, right there. But do you see it for each 1 unit increase? No, you're fine. Let me throw you 5,000 more points. Don't worry. Go out on these limbs. But we'll do it more times as the test approaches. We'll do it again. And just try saying it. Try writing it. For each 1 unit increase in x, we expect y to increase or decrease by b1 on average. So for each 1 unit increase in fiber, we expect potassium to increase by 28 on average. So the model predicts that the cereals will have an increase of about 28 in potassium for each additional gram of fiber. So for each additional gram of fiber, we expect the potassium to increase by this amount. So they do it a little bit out of order, but there's for the each additional 1 unit increase in x. I'm kind of blocking it. So once again, if you write this out and know how to do it, it's a little bit easier with finding them. If it has a negative residual, that means its actual potassium is lower. So the cereal, its content of potassium is actually lower than predicted. Yeah. If it has a negative residual, it's lower than predicted to be. The car predicts what? 5-liter engine? Cannot do the full thing. We did a lot of the hard ones. There's that. 1 decimal. Going backwards. How much potassium does the estimate you'll gain? So we're just using the model. So 8 times 28 plus 37. There it is. Predict using the model. No one wants me to do those. R squared, what is the correct interpretation? 20.7% of the variation accounted for by the model. Call it variation instead, my Pearson. Blank percent of the variation, y. What is the value of R squared? We got to go find it. Find R squared, copy it in, go over here. You don't click your snapped keyboard, drop it in, analyze, fit y by x. Price is the y, this is the x. Run the model, create the model, fit the R squared. 9.97, 97.6. 2 decimals, 97.46. About 97.46% of the variability in the price of a hard drive can be accounted for by a linear model on capacity. Check answer right there. Next one. The correlation between this, what is the R squared? Variation explained. R squared is that. So then we times by 100. We move our decimals. And we get the R squared. We round to the nearest tenth. That should be good right there. I didn't round up. I saw it. Come on. That's close enough. You got to be all right with that, my Pearson. There we go. Good stuff. Speed running this. What is the variability accounted for? They're just showing you that, well, it doesn't matter. It's negative or positive. There we go. 50 point nearest tenth, 50.8. 50.8. There we go. That solved out. And then right here, speed runs. That's what one speed runs. 71.1% of the variability in price can be explained by the variation in home size. Really, 71.1. So it's got to be the other one. size accounts for. So they reverse my x and my y. So 71.1% of the variation in home price can be explained by the variation in size. Come on, don't reverse my x and my y on me there. Don't reverse. I'm doing it quick. First one looks random is good. It's appropriate model. Second one shows a curved pattern. That one has a bit of an outlier. Did they mention it? Single point. Good. They mentioned the outlier. Good. This one right here. What do we got right here? What are the variables together? It's going to be, I know I'm just doing it for funsies. It's year and daily water consumption. So water consumption in gallons. That's what are the variables? In millions per person, I think they want. What are the units? It's millions of gallons per person per year. What is the correlation right here? They want us to run it. Oh, wait, no. It's up here. Look, we can take the r squared and go to 0.928 and square root it, but it has to be negative. Do not forget the negative. That is very important because it is a negative correlation. So we got that. And last but not least, this is the roller coaster one. We did this one a few days ago. So we do a lot of these. We talk about the roller coaster one, that rides that have bigger drops have longer rides. So the predictor variable, which is the x, is the drop, which is going to be in units of feet. And the response variable is how long does it last? And that's going to be in units of seconds, which is how many we're predicting, how many, what is the slope has is for each additional foot we drop, the ride will last an additional second. The slope is probably going to be positive because rides with bigger drops are probably going to be longer rides. So there we go. We should do it. We got one thing wrong. What have I done? Seconds per foot. For each additional second. Yeah, seconds of... That's the way it's phrased. Well, we never asked. Thank you, Zachariah. 5,000 points. We've never asked a question on the test, like what are the units of the slope? It's... the y per x. Yeah, per foot. Each additional second per foot of drop. That makes sense. Because, like, for each additional 1 unit increase in x, we expect y to increase by b1 on average. So I did this on another office hours, but I was just going so quick. Makes sense when you say seconds of ride per foot of drop. So we did this a few days ago, and I drew it out. And, like, rides with longer drops, that's you right there, are going to have a longer duration. So for each additional 1 unit increase in drop, like in feet, then you get more seconds. So it's seconds per foot of drop. Cool beans. Well, we did it. We completed every question. So every single quiz question has been mentioned. Really didn't do a full deep dive into each question, but I just wanted to kind of have some fun and just do them. And I mean, we did them in 5 minutes, 6, 7, 8 minutes. So we just did like a minute per question. Some of them are really easy though, like what is the slope? What is the intercept? How would you predict with the model? What's a residual? Things like that. With that, bye for now, everyone. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.